Hello,
Hello,
my name is Sofia Rutska.
my name is Kateryna Vashchenko. This work was made by Oleg Rudenko, Oleksandr Bezsonov, Sofia Rutska, and Kateryna Vashchenko. It's always a big problem to prepare a good dataset for neural network training. Usually, it's impossible to take many pictures of real life scenes because of privacy, ethics, and costly equipment. In this work, we consider synthetic data utilization generated from 3D models of the objects. As an example, we choose the task of recognizing risk requires at the scenes of disasters to better coordinate their actions in a full-scale war in Ukraine.
It's also very difficult to get annotated photos. Annotation is a selection of the right object by contour. Imagine you want to outline one person. That's a lot of dots and line and hours of work to outline just one person. Annotation is monotonous because it's a processing of thousands of images. In our project, we intend to make it automatic action.
We are not the only ones who have noticed the use of synthetic data. Microsoft creates realistic, multifaceted, and lifelike synthetic faces. It starts with a universal face template and then applies random combination of personalities, expressions, textures, hairstyles, and clothing. For example, article a systematic review of deep learning-based image synthesis in medical imaging. This article examines the application of synthetic data to improve the training of deep neural network in medical diagnosis and treatment tasks. Article synthesis data generation for tabular health records a systematic review inspired us to use and study synthetic data. It provides an overview of recent research on the use of synthetic data generation techniques for health records.
Synthetic data can solve a large amount of problems of a deficit of real object images. For example, increase dataset for machine learning. When there is not enough data to test or when privacy is the top of priority, synthetic data can replace real images. First, you can quickly and cheaply produce as much data as you need. The synthetic data can have better annotations. The synthetic environment can be modified to improve the model and learning. Synthetic data can be used to resolve privacy concerns. Neural network training can be performed on fully or partially synthetic datasets. At the same time, test set must contain only real objects. Synthetic data, which refers to artificially generated data that mimics real-world data, has a wide range of potential application across various industries. Here is a few examples of where synthetic data can be used. It's machine learning, autonomous vehicles, video game development, robotics, security, and fraud detection.
Overall, synthetic data has the potential to be used in a wide range of applications, where real-world data may be difficult, expensive, or impractical to obtain. By generating artificial data that mimics real-world scenarios, synthetic data can help to improve the performance and accuracy of various systems and algorithms across different industries.
Deep learning algorithms, in particular the convolution neural network (CNN), have gained wide acceptance as a robust approach for learning predictive features directly from raw images. The basic principles of feature extraction with the CNNs still apply. CNNs scan every pixel of an image and store information based on the pixel value patterns.
We used the Mask-RCNN neural network because it's a fast and reliable neural network for detecting object in the image. The searched object is highlighted on the contour with the help of a mask. The concepts behind Mask-RCNN have undergone a step-by-step development through the architectures of several intermediate neural networks that solve different problems. Mask-RCNN was development from Fast-RCNN, a region-based convolution neural network, by adding a branch for predicting segmentation masks on each region of interest, in parallel with the existing branch for classification and bounding box regression. In convolution neural network, which are widely used for image processing, cross entropy can be used to train the network on classification tasks. Typically, the last layer of a convolution network has a softmax activation function that converts the network outputs into probabilities of belonging to each class, and the cross entropy is used as a loss function for training the network. The stochastic gradient descent algorithm is used to train the convolution neural network formula on the slide.
In our work, we followed this order. First, you need to find or create 3D models of the object being explored and 3D models of environment. Then render the image, and if it's enough, you can move on the next step. With the 3D models, it's easy to make masks, and with software calculation, you can find mask boundaries. The coordinates are saved in a JSON file for future processing and saving the object boundaries. This is how annotations are created. In the process, we change the appearance of the background in many ways. We added destroyed cars and houses to fully replicate the scene of the city photo. We added different weather conditions, such as rain and snow, which will eventually make up the complete scene.
This project used Blender, professional free and open software for creating 3D computer graphics. 3D models also make it easy to create masks of the object in a single click. In Blender, it's possible to animate characters or different objects. You can see examples on the slide.
The annotations are needed to mark the boundaries of the desired object. Of all programs, we decided to use VGG Image Annotator. It's a simple program, but it takes a long time to process a single object. We developed a program that receives the coordinates of the object boundaries. It speeds up annotation process. Just load the image and its mask into the program. The mask is a photo with a completely black background on which the object is marked in white. The resulting point coordinates in a JSON file are loaded into VIA, and mark area appears on the object, making it easy to annotate.
Our dataset has also been augmented. It's when the photo mirroring, rotating of varying degrees, etc. After modifying the photo, the object's boundary points change. They now have different coordinates, and our program sets them automatically. We trained the neural network on a test set that contains synthetic images. After training, it can detect objects already in real images. We ran this neural network using cloud services, which allowed us to use Google GPUs. Processors are expensive and not everyone can afford them. So this method simplified the work and saved money. After training, the neural network found the objects in the image and highlight them using a mask. After testing the neural network, it turned out that out of 150 real photos, about 40 are not recognized accurately. This can be solved by increasing the neural network training by a large number of steps. In a situation where there is no way to take photo, It makes sense to use synthetic data. That is what is done in programs such as Blender. The resulting images need to be annotated.
For thousands of photos, it can take days or weeks or even months making points on a contour, especially difficult if it does not have a perfectly straight shape. We write in a program that will do the annotation in just a couple of minutes. And on the resulting synthetic images, we trained a neural network that already recognized the objects we need.
Working on the project gave us the idea that it could be incorporated into the development of the VR glasses industry. For example, for an operator who coordinates the work of rescuers, they allow seeing literally in front of him in real time. This technology can find any object in the image and it may be used everywhere. Thank you for your attention.
Thank you for your attention.
Goodbye.
Goodbye.